All right, geometry students. So today we are moving into our final triangle congruence theorem that is called HL. And this pertains directly to right triangles. We should be able to determine whether a pair of right triangles are congruent using the HL congruence theorem. And this is a pretty quick video. We're just going to look at the congruence theorem and a proof. So make sure you're following along with our guided notes and let's get started. So, like I said, the HL congruence theorem is the hypotenuse leg congruence theorem. Let's quickly remind ourselves of the anatomy of a right triangle. Obviously, there is the right angle. The hypotenuse of a right triangle is the side that is directly across from the right angle. So, side BC in this triangle is the hypotenuse. The leg, there's actually two legs in a right triangle. Legs are just the sides that are next to the right angle. So BA and AC are both legs. So essentially what we are saying with this theorem is that if the hypotenuse and one leg of one right triangle is congruent to the hypotenuse and a leg of another right triangle, then the two triangles are congruent. Now, once again, let me remind you, this theorem cannot be used for any triangle except for right triangles. For other triangles, this would be called angle side side, and we know that is not a congruence theorem. So let's just break down what this means. If the hypotenuse, for us that means BC, is congruent to EF. If BC is congruent to EF, and a leg, in this case, BA, is congruent to ED. If the following is true, and we know there's a right angle in here, then we know that triangle ABC is congruent to triangle DEF. Hypotenuse, leg. And it can be either leg, it doesn't matter which leg. So let's try out a proof with this information. So we're going to try out number 2. And number 2, we are given triangle WVX and triangle YZX are right triangles. We know that side WV is congruent to side YZ, and we know that X is the midpoint of WY. So that's a lot to take in. And we need to prove that triangle WVX is congruent to triangle YZX. So let's start with our given information. I'm going to start with WV is congruent to YZ. And of course, the reason is that is given. And as I go, I'm going to label the congruent information. So WV is congruent to YZ. Then I'm told X is the midpoint of WY. X is the midpoint of WY. That's also given. So WY is here, and it's cut in half by the midpoint X. So since midpoint cuts segments in half, we know that WX is congruent to YX. The reason is that's just the definition of a midpoint. That's what midpoints do. And we also know that triangle WVX and triangle y, z, x are right triangles. I'm abbreviating a little bit here. That's given information. And since they are right triangles, I'm going to have to assume the only non-acute angle in these triangles are angle V and angle Z. And so you can see here now, the triangle on the left, WVX, it's a right triangle, and it looks like the hypotenuse of this triangle, labeled with the 2 tick marks, and the triangle to the right angle is angle Z, and the hypotenuse is XY. We also have one leg of each triangle labeled as congruent. So from here, we have hypotenuse, leg. Triangle WVX is congruent to triangle YZX, and that is due to hypotenuse, leg. If you'd like to try out an additional problem, try out problem 1. For that problem, the statements are provided to you. So that is it for our video. Thanks for watching. Make sure you try out the additional practice problem. Check your answers with my filled notes and ask for support in Math Help Desk if you need it. Have a great day.